Hello, I'm Guy, and this is Guy Robot.
Hello! Over the last couple of weeks, I've been getting back into cryptocurrencies. In particular, I've been looking at those that are CPU or hard disk based mining, so I can make the most of the hardware that I've got. While I was doing this, one of the currencies I was looking at, Burstcoin, is a hard disk based one, and I thought, well, could I get anything useful using a Raspberry Pi to do the mining experience? And I thought probably not, and actually it would be useful to see what the performance was like. So I decided I would write my own CPU miner that would run on a Raspberry Pi, but I thought I also want to have it run on Windows, so I've got some use for it, presumably because the Raspberry Pi doesn't have USB 3 and it won't be that great. So I decided I wanted to do cross-platform development. Now, .NET Core is the obvious answer for me. It's Microsoft's latest, over the last couple of years, direction that .NET is going in. So .NET is very loosely the Microsoft equivalent of Java. .NET Core is the same concept, but it will run on loads of different platforms. So it will run on Windows, it will run on Mac OS, it will run on Linux. .NET Core 2 takes that further and also adds multiple CPU architecture support, so you can run it on Linux on ARM, you can run it on Windows on ARM, you can run it on the Windows IoT ARM Specialist Edition one, you name it, pretty much it can run on it. So that felt like a good idea. Now, it's very new getting a Raspberry Pi up and running with .NET Core, but surprisingly easy. So I thought I would do this quick run through showing you how to get .NET Core up and running on your own Raspberry Pi if you fancy writing some cross-platform code. Let's go. So the first thing we need to do is actually set up our Raspberry Pi. I'm going to do a quick run through of getting the image for the Raspberry Pi and installing it, just in case you're not that familiar with it and you want to start using a Raspberry Pi for running .NET. So the first thing we need to do is actually stick Raspberry Pi image onto an SD card. I've got an SD card and a reader here. So I'm just going to pop this into my computer. And then we have a choice of different images that we can download. Now, a lot of people use the Raspbian image, which is like a Raspberry Pi Debian image. However, in this case, it's a lot easier to get up and running with Ubuntu for .NET Core. You can do it with Raspbian, you're probably going to have to compile a few things yourself or just work with the binary distribution. But if you want to actually have the whole of .NET Core on there, then it's a lot easier to get going on a supported distribution. And Ubuntu is probably the best supported on Linux at the moment. So let's get a version of Ubuntu for it. So we can do that by going to the Ubuntu Flavor Maker website. The links to everything are going to be down below in the description, and also check out guyrobot.tv where the blog post has full step-by-step instructions of how to do all of this along with all the links. Then you've got a bunch of different images that you can download here. Now I'm going to download the classic server for Raspberry Pi 3. You've also got different versions for different hardware. Classic server here works well, so that's what I'm going to go for. Just whack all that, save it, and wait for it to download. The next thing we want to do is to actually put that image onto the memory card. Now we need to know which device we're putting it onto. So I just put the memory card into my machine. So the easiest thing to do in Linux is to type in dmessage, which shows you the kernel log messages. And from that, you can therefore see what's just been inserted into your system. So in my case, if you see down the bottom here, the very last thing that's happened is SDC has been added. And that will normally show up as SD and then a letter, depending on which other drives you've got installed in your system. So SDB for me is a USB drive that I've got attached. SDA is one of my internal SSDs. So once we know which device we're going to write it to, we're good to actually write the image to the disk. So the first thing we need to do is unzip the image that we just downloaded. If you download the same image as me, it's got an XZ at the end, so that's nice and simple. We just do unxz and then the file name. Whack enter. Now this does take a while because XZ is efficient but also a little bit slow, particularly with this large image, so jump cut. So there we are, it's now extracted. So the next thing we want to do is write that to disk. So first off, let's double check where we're writing it. Let's do dmessage again. We are good with that being SDC. So the next thing we want to do is run DD, which is a tool that takes from one input stream and outputs to another. Now files, disks, they're much the same in the Unix world, so we can just read from a file and output it to a disk. So we double check the name of our file, excellent, and then we run this command. You've got to sudo it because you're writing to a disk. So sudo dd is the command, if is the input file, of is the output file, which in our case is the disk, and then BS is the block size that we're writing, 1 megabyte. So all we have to do is run that, type in our root password, rather our sudo password, and it gets going. After a short while, that should write your memory card. Depends on the speed of the card and your USB port and your reader and everything else, how long that will take. In this case, it took just under a minute. And we're done. We can now take the memory card out and pop it in the Raspberry Pi. Okay, and we're ready to power on the Raspberry Pi now. So if we apply power, hopefully, we should get Ubuntu starting to boot. Now, this is currently recording off my monitor, so the quality isn't going to be great. So what I'm going to do is, as quickly as possible, revert this onto an SSH connection so I can capture quickly. So we're going to do a quick jump cut to this having booted first of all. Right, there we are, and it's booted. Now what I'm going to do is jump onto the second terminal so we don't get console messages in the way. This takes a few seconds more to boot up normally, but it should be here in a sec. There we go. And then you need to log in as the user Ubuntu with the password Ubuntu. Now there is one slight problem with this in that I actually have a Dvorak keyboard with a QWERTY layout here. So I've got to try and remember which keys are which. Oh, that's good. Then you have to change your password. So excellent. There we go. And once we've logged in, all I want to do for now is know the IP address to make sure that I am able to connect to this remotely and then get back to doing proper capture. So we do IP ADDR. And you can see towards the bottom of the screen now it's got 10.0.1.242 on there. So on my other machine, I'm going to quickly go, can I ping 10.0.1.242? Yes, I can. Can I SSH to it? Yes, I can. So with that, I'm going to jump back to one of the computers so we can actually get some decent capture going. We've now booted the Raspberry Pi and we've changed its password. We know its IP address. Now off camera quickly, I've given it a static IP address as well. I'm not going to run through all of that here because it's not really relevant. It's just going to help with some networking things on my local network. There are loads of configuration guides if you do want to set up a static IP address for your Raspberry Pi. The next thing I'm going to do is connect to it via SSH. So it's a new host, going to connect to that. Once we're in, we're going to escalate as root. Now, one of the first things you'll notice on this image is whenever you escalate, you get unable to resolve host Ubuntu and then some various errors depending on how it's configured. That is the local host. For some reason, whenever this was set up, it wasn't configured in the hosts file. So the easiest thing to do is edit/etc/hosts. And then just ensure that next to your localhost one, you've got Ubuntu written there. Next time you do a sudo or do any other login, at least it can ping its own host name. Ta-da! Right, once that's done, we're now ready to actually start installing things. Now the key thing with .NET is we have a bunch of prerequisites we need. First thing we need to do is an apt-get update to make sure we've got the latest package tree. Once that's all done, then we're ready to do an apt-get and do an install. So there's a bunch of packages we need. So the first one is WPA supplicant, which is for configuring your Wi-Fi. You only need that on a Raspberry Pi 3 if you want to configure Wi-Fi on it. Then we have libunwide8, libunwide8 dev, gettext, libicu, libl curl4, SSL. Basically, these are all new UID. These are all things that .NET Core needs in order to run. So we're just going to press enter and get that going. Now something that's worth noting here, what you might see at that point, let me go yes, what you might see at that point is an error saying that file's locked and you're unable to use it, even though you've used sudo and you're authenticated. Now that's because the auto update on the device has kicked in and it's updating a bunch of packages. If you do see that, it can take up to half an hour or so on the Raspberry Pi to do it. Hopefully you'll get in before it does. You may as well let it go. It's just upgrading some of the latest security updates. It's worth doing. If that does happen, you can monitor the process of it by looking at top C running processes in another tab, or just go and get a cup of tea for half an hour and come back. Now this will take a while to run, so we're going to just jump to the end of it. And once that's all done and everything's installed, the next thing we actually are ready to do is start installing .NET Core. So currently 2 is in beta, so we're going to pull the latest down. It should be released final, I would imagine, pretty quickly, and frankly this seems a really stable build from what I've been doing. I would certainly recommend pulling down 2 rather than the 1.x branches. Even in its current state, it's so much better than the 1.x ones. So we're going to do a wget, and we're going to pull down the latest ARM version of 2.0.0. These are all available on GitHub as well. This is just a direct link to it. If you want to change to x86 or 64-bit, just change ARM for x64, and you can then run these same steps on an Ubuntu desktop machine. So we're going to pull that down by wget. It's not going to take long. It's only a few megs. So once we've got that downloaded, the next thing we want to do is create a folder to put this in system-wide. So I'm going to put it in /opt/.net-2.0.0. Then go into opt.net 2.0.0, and I'm then going to uncompress that tar.gz to that folder. Once that's done, I'm going to remove the tgz just to tidy up. You can see we've now got our .NET file. Next thing I want to do is put that in the path somewhere. So the easiest thing to do for that is go to user local bin and then create a symbolic link between opt.net 2.0.0 and .NET within user local bin. So now if we look for .NET, we can see that that redirects there, and then anywhere on the system I can type in .NET and we appear to have it installed. Next thing we need to do is test whether it works. If you want to be really happy you've got it installed at this point though, what you can do, if we go in here, you can see that we've got the .NET executable. You can do ldd .NET to see all of the things it links to. Now you will notice that none of these got not found next to them, which means it's found all of the dependencies. And if we go into the actual SDK folder as well, and we look for all the shared objects, we can do the same here, ldd star.so, and if we do a grep through not found, you can see there's no errors. So that means that there is nothing installed for .NET that we haven't got dependencies for now. So it should all just run and work, which is pretty cool. So the next thing we need to do is actually upload some .NET code. So if I create another terminal, I then SFTP to the host to do an upload, and then I put a file which I've already got there. I then uncompress this, go into my Burst Sharp folder, and you'll notice I have a bunch of DLLs. This is all code I've built in Visual Studio in Windows targeting .NET. So I've built this on a 64-bit Windows system. It runs in a 64-bit Windows system, and all I've done is literally just copied that same code from a Windows 64-bit world onto my Raspberry Pi. I'm now going to run .NET and then give it the executable name, which in my case is minor.dll. Ta-da! It starts up and runs. So this is now going to run exactly the same as it would on my Windows world. In fact, if we want to, we can go over to Windows and see how the same application looks over there. And now we're in Windows, we can do exactly the same again. So we can do .NET minor.dll. We've got exactly the same thing running on a different platform. I've written the code once and it will run on Windows, it will run on Linux, it will run on a Raspberry Pi with ARM, it will run on any ARM board actually that you can install Ubuntu into, or any other Linux distribution if you want to deal with the dependencies yourself. It will run on Windows on ARM, it will run on pretty much anything. So the .NET Core 2 framework is awesome for allowing you to do that, and it's actually really easy to install on a Raspberry Pi. I mean, what did we actually do there? We installed an Ubuntu image, we did real bit basic configuration on it, ran a couple of apt-gets and uncompressed a tgz, and then bang, we've got .NET Core installed on there. The other thing you can do, you don't even need to do the step in, if you're just going to run .NET applications, you can also get packaged executables with all the dependencies and stuff built in, which means it's even easier to run on the target platform. You don't need to go through the apt-get and everything. But I find for when I only want to transfer a couple of DLLs around, this is a much better way to do it. It's also less bulky for your distributions and things as well. In fact, we can see how easy this is to do a project if you want. I will very quickly open Visual Studio and we'll just create a really simple hello world that will work on both Linux and Windows. So we're going to just do a new project. We're going to choose a .NET Core console application. We'll just call this rpi-test. Go into Solution Explorer, open program.cs, and then in here we've already got a basic hello world application. So I suppose what we can do at that point is just read someone pressing any key. Then when we do that, we'll make the background of the text green, and we'll make the foreground of the text next red because that will look hideous. We will go to top left corner of the screen, and then we will write some more hellos, and then it will end. So if we run this from Visual Studio in Windows, it will build the code out for us. Press enter, there you are, writes it in lovely green and red. Then if we get where that folder is, so this, remember this has just been built in Windows, x86, grab that directory name and connect to our Raspberry Pi on the ARM hardware again. We log in, we'll create a new folder for this, we'll change to the local directory we've just built it in, upload all those files, and then if we go back over to the Raspberry Pi, we've got our RPi test folder, and then we can just on here do .NET, what do we call it, RPi test.dll, hello world, press enter, and then it goes to the top of the screen and overwrites it. There we are. That is how easy it is to write and compile some code that will run on a Raspberry Pi, on Windows, on a Windows ARM tablet, on a Windows server, on Mac OS, pretty much you name it, you can run it. Hardware, CPU architecture, and the performance is incredibly good as well. Super easy to do, and there we have it. And that's it. It's easy, it works, there's cross-platform development. I've done some tests on my miner, and unsurprisingly, it doesn't work amazingly on a Raspberry Pi because you are limited to the USB 2 bandwidth, both in terms of the network and also in terms of any direct attached disk I/O. Now, would this be fast enough to do some kind of mining on it? Yeah, it's not going to be earth-shattering though. So definitely not going to be the one for hard disk mining, although there is some potential for CPU mining of other coins with it if you scale them out for incredibly low power usage, because the power draw on that thing is tiny. A Raspberry Pi 3 fully loaded, mine's pulling in 0.3 amps usage, which is barely any power if you scale them up. So I might do some benchmarking on that. But the main thing for now is I have .NET Core up and running. I'm probably going to do another video doing the same thing, but getting Windows 10 IoT, which is Microsoft's free special edition of Windows that is expressly designed to run on IoT devices, including the Raspberry Pi. So it's an ARM-based version of Windows 10 that's massively cut down, and it just runs kind of a single app, including .NET applications. So should be able to get .NET Core up running on that, although I haven't tried it yet. So I'll probably do that in a future video. If you're interested in that, or you're interested in any of my mining that I've been doing for Burstcoin, Raicoin, or any of the other cryptocurrencies, then do let me know. Leave a comment below. If you like this video, thumbs up. If you thought it sucked, thumbs down. And please check me out on Twitter at GuyRobotTV. All of the details of everything that was in this today, including step-by-step instructions, is over on my blog at guyrobot.tv. And don't forget to subscribe. Thanks.